Hey, and good morning to you. So, hopefully, you're having a great day. All right, nothing better than to get your day started like I am with a little bit of math today. All right, we're working into our final two lessons for our unit on exponential logarithms. And what we're going to do today is solve exponential equations. And then tomorrow, we will wrap up the unit with solving logarithmic equations. So here's what I'd like you to do is just look at the opener there, 2 to the power of x plus 3 equals 16, and see if you can figure out how to solve for that. What would x have to be for us to get 16 there on the right side? So I'll give you a few moments, pause the video, flip it back on, and let's see how you did. All right, so let's take a look. Really what this comes down to is what we know is that 2 to the fourth is 16. All right, so if 2 to the fourth is 16, that means that the exponent here has to be, all right, x plus 3. So x plus 3 has to equal to 4, which means x had to equal to 1. So really what's happening here is we're trying to match both sides in terms of the same equation. So if I have 2, let me switch to a pen here. All right, 2 to the x plus 3 on the left, right? And if I can rewrite the right side as a power of 2 as well, right? So 2 to the fourth, right? If the two bases are the same, that means the exponents have to be the same in order for the left side to be equal to the right side. And so that's really what's happening when we get to this x plus 3 is equal to 4. We've really matched the left side to right side in terms of base 2. And that's really the key to solving the first type of exponential equations that we're going to look at. All right, so maybe, oh, there we go. All right, so here's what we want to do, right? Is can we get both sides of our equation in terms of the same base? All right, because if we can get b to the n equals b to the m, then that means n has to equal to m, which means then we can solve, all right, for that variable, much like what we did in the prior problem. So what this means is you might start with the same base on both sides. That's really simple. You might have to take one side and turn it to the base of the other side. You might have to turn both sides in terms of the same base and use some properties of exponents along the way. All right, so let's take a look at number 2 here. All right, and what you can see with number 2 is that we have base 4 on the left, we have base 4 on the right. So if these two things are equal, that means that the exponent on the left, all right, which would be x minus 9, has to equal to the exponent on the right, which is 2x plus 3. And now this is just a very simple equation to solve, right? And so if I do that, I can subtract 3 from both sides, so that's negative 12. I can subtract x from both sides, and that would just be x. So I get that x is equal to negative 12. So notice I didn't have to do any manipulation. I really didn't have to do any work because I have the base on the left is equal to the base on the right. Now, if we look at example 3 here, this is very similar to what we did in the opener, right? I've got base 2 on the left, and I've got 16 on the right. So the question is, can I rewrite 16 in terms of base 2? And of course, we know the answer is yes, because we did that in the opener. So then I can say, okay, well, then I have 2 to the 3x minus 8. And that equals 2, and I'm going to rewrite my right side in terms of base 2. That would be 2 to the fourth. All right, and now, once again, the bases match. So then what we know in order for the left side to equal the right side is that the exponent on the left, which is 3x minus 8, all right, that has to equal the exponent on the right. Okay, and that tells us that 3x has to equal to 12. And that means that x has to equal to 4. All right, so we may not have to manipulate either base. We might have to manipulate one side. Now when we look at number 4, this is an example of where we look at, we have base 27 on the left, base 29 on the right. And so now the question is, okay, do 27 and 9 have a common base? And the answer is yes, and that would be base 3. Now, the key to this is we have to remember a certain property of our exponents. So now 27 is 3 to the third. So I'm going to have 3 to the third. But now remember, I'm still raising that to the x plus 3 power. All right, so x plus 3, right? Equals, and 9, if I rewrite 9, is 3 squared. So that would be 3 squared. And remember, that is still being raised to the x minus 1 power. Now, here's what we have to remember is, what do I do when I have a power to a power? And we do multiply, all right, those powers. So now my left side would be 3, all right? And then if I multiply, now remember I have to multiply both things. So this is going to be 3 times x plus 3, which would give me a power of 3x plus 9. And then on the right side, once I distribute, I have to do 2 times x minus 1, so that's going to be 3. And then that would be 2x minus 2. All right, so now left side matches right side, so now the exponents have to match, right? So 3x plus 9 has to equal to x minus 1. All right, and so that means that 2x has to equal to negative 10. All right. Oh, sorry, I just totally messed that up. So let me erase that. I don't know what I was looking at there, but that right side is an x minus 1. All right. Maybe, come on. All right. All right, so that right side is 2x minus 2, which means now that should be x equals, and that should be negative 11. All right, so what I would like you to do now is try 5, 6, and 7 on your own. So go ahead and pause the video, work those 3 problems, and then either check your work on the Fully Works note sheet or flip the video back on. All right, so let's take a look. I have those 3 problems worked out on my paper here. All right, so number 5, we only have to manipulate one side of the equation to get started. So the left side is in terms of base 5. All right, so I have 5 to the 3x minus 6. And so now I want to rework the right side to be in terms of base 5 as well. So 125 is 5 to the 3rd power. Now notice when I do my power to a power property, I get 5 to the 3x on the left. So now my bases match, therefore my exponents have to match. But notice what happens here. I get negative 6 equals 0. Well, what that tells me is that there's not a solution to this problem. So those things that we know about getting no solution still apply if it works out to be so once we're solving for x. All right, so problem 6. All right, we have to manipulate both sides of the equation in order to get in terms of the same base, because 8 and 4 are both, all right, powers of 2. So 8 is 2 to the 3rd power. 4 is 2 to the 2nd power. Now, once again, when we do our power to a power property, 3 times x minus 2 would be 3x minus 6. And then 2 times x minus 3 would be 2x minus 6. Base on the left matches the base on the right. So 3x minus 6 has to equal to 2x minus 6. All right, we subtract 2x from both sides, add 6 to both sides, we get x equals 0. Now, nothing changes if we have base e. We treat it just like any other base. We just want it to match. Right, I have base e on the left, base e on the right, so that means that the exponents have to match. So 4x minus 3 equals 6x plus 10, which means 2x, negative 2x has to equal to 13, and then when I divide both sides by negative 2, I get negative 6.5. All right, so that's really the first type of problem that we have. Now, let's look at, all right, when we have something like this, let me see, I think it's at the bottom of our page here. Scroll down, scroll down. All right, so what happens when we have something like this, right? 4 to the x equals 18, right? We can't get 18 in terms of base 4 because 18 is not a power of 4. So this is really where a lot of the work that we did last time, all right, comes into play here, because what we want to do, all right, is take the inverse, all right, of 4, or base 4 here, in order to solve for x. All right, so this is where what we did with our finding inverses last time is that if I want to solve for that x, I'm going to take the inverse of base 4, which would be log base 4 of both sides, right? So much like what we did all right, when we are solving for inverses. And that would equal to, all right, log base 4 of 18. All right, now, log base 4 of 18 is a number. All right, it's like the square root of 3 or the square root of 7 or something like that, right? It's an exact answer, and we can leave it looking like that, and we don't need to do anything else to it. Now, unless we simplify some way, then you could do that. But leaving it as log base 4 of 18 is an exact answer, and then we know based on our work with inverses that log base 4 and base 4 inverses, and so that leaves us with just x equals, right? And then that would be our answer right here. So log, as slow as it's writing, all of a sudden everything on my computer is really bogging down, of 18. And that would be our answer. So the idea is that if we can't get it in terms of the same base, we're just going to go through our normal solving process and then just take the inverse at the end, just like what we did when we were solving for inverses in our last lesson. So let's look at a couple of situations together, right? All right, so I'm going to look at number 8 here. And so notice, one, that we have an exponential here on the left, but it's not isolated. So the first thing that we want to do is isolate that exponential expression and then see if the right side or the opposite side can be written in terms of that base. If it cannot be, then that's when we do the inverse log and then we solve for our variable. So let's switch to red here. All right, so let's start by isolating that exponential, which means I want to subtract 3 from both sides. All right, subtract 3 from both sides. All right, so 4 to the power of x minus 2 equals to 15. All right, so now I've isolated my exponential. Now, can I get 15 to be in terms of base 4? And the answer is no. So now what that means is I have to take the log of both sides. Well, what's the inverse to log base 4? Or excuse me, to base 4? It is log base 4. Gave away the answer there. All right, spoiler alert. All right, so we have log base 4 of 4 to the x minus 2 equals log base 4 of 15. Now remember, log base 4 of 15, all right, is an exact number, so we can leave it like that. Log base 4 and base 4 inverses, and so that leaves us x minus 2. And then we can still have our log base 4 of 15 right here. And then our final step to solve is to add 2 to both sides. And then once again, I'm just going to add that on out here. All right. And so we get x equals, and we have our log base 4 of 15 and plus 2. And so that's an exact answer right there. Now, just talking about mechanics, what you'll see is a lot of people will jump from this step to this step. They won't necessarily write this, all right, in between. I'm doing that for emphasis right now to help you see exactly what's happening, but know that some people will jump that, and that's totally fine. Okay, so now let's look at number 9. So once again, we always want to start by isolating that exponential, right? And so what I need to do now is start by adding 19 to both sides. So I'm going to add 19 to both sides. All right. And notice that this problem is going to have an additional step in it. All right. So I have 5, and I have 7 to the x plus 4. Equals, and then I think I get 50 or 42 here. So let's see, 30 plus 12, yeah, so 42. And so here's that additional step, is because now, all right, I have to get rid of this 5 right here. So I need to divide both sides by 5. So there's the additional step right there for you. All right, so I get 7 to the power of x plus 4 equals 42 divided by 5, which is 8.4, right? All right, so now what we want to do is undo our exponential. And so the inverse of base 7 would be log base 7. All right, and so we want to write that out, not down here. All right, so there we go. All right, and then once again, log base 7 and base 7 undo each other. Now I'm going to kind of come up here under 10 here and finish the problem because we were going to have x plus 4. And that's going to equal to log base 7 of 8.4. And then my final answer, I'm just going to subtract 4 from both sides to get my final answer here. So x equals, all right, log base 7 of 8.4. And once again, that's just an exact number. And then minus 4. And then that's your answer. All right, so I did 8 and 9 with you. So what I would like you to do is pause the video, give number 10 a go, and turn it back on. Let's see how you did. All right, so I took 10 and had it and did it on a separate sheet of paper anyhow, which turned out to be very good since I took up all the space there with number 9. All right, so once again, all right, want to try to isolate our exponential. So hopefully you subtracted 9 first and then divided by -2. And you get to a step where you have 10 to the 3x minus 5 equals 26. Then once again, we can't get 26 into terms of base 10. So we'll take the log of both sides. Now remember, if it's base 10, it's just the common log. So log of 10 to the 3x minus 5 equals log of 26. These undo each other, is equal to 1. So I get 3x minus 5 equals log of 26. I have to add 5 to both sides. All right, and then now this one has an additional step that the prior problems did not, because I have this 3x right here. So I just have to divide everything by 3. So my final answer is log of 26 plus 5 divided by 3. Okay, now that really does it for the solving part. But what I'm going to show you now is if you need to get like an exact answer on your calculator, all right, how do you do that? All right, because if you look at your calculator, and I have my calculator open over here, notice you only have 2 keys. You have the log and you have the natural log. All right, so if I wanted to know what log base 7 of 8.4 was, I have to do something in order to use my calculator because it doesn't have log base 7. All right, and we don't have enough keys, right? Because there's an infinite amount of log bases that we could have. So a formula, and we're not going to develop this formula, we're going to kind of give it to you so that you can use it, is what we call the change of base formula. And so what this allows us to do is change from any other base into either log base 10 or log base e, so the common log or the natural log, in order to find an exact answer. And it's not a real complicated formula, all right? It really just says if we have log base b of m, that is equal to log of m divided by log of your base, or natural log of m divided by the natural log of your base. And it doesn't matter if you use the common log or the natural log, you're going to get the same answer. So for example, if we have log base 7 of 13, and I want to know what is that exactly, what number is that, all right, I would say, okay, I'm going to use my change of base formula, and I can say this is going to be log of 13, right, divided by log of 7. Maybe. All right, just like that. Okay, and then I can just come to my calculator, and now I have a key here. So I can do log of 13, all right, divided by log of 7. And you can see that I get 1.3. Now, notice if I did natural log of 13 divided by the natural log of 7, notice I get the same answer. All right, so whether you decided to write it on terms of the common log or the natural log, it doesn't really matter. All right, so here's what I'd like you to do is just pause the video real quick. Let's just do one together here. Why don't you convert 12 to a decimal, all right, and see what you get. All right, so if you're using the change of base formula, all right, you should have log, and this is like super slow. Luckily, we're just about done here. All right, of 22 divided by log of 13. All right. And so now if I come over, and hopefully you did the same thing, if I go log of 22, all right, divided by, there we go, log of 13. All right, we get 1.2. All right, now I wanted to say 13 because notice if we do this here, that we have to take some other things into consideration. So if I did my change of base formula, notice my numerator, oh man, my numerator would be log of -3. Now, here's what we have to remember. Oh man, besides this going crazy. Oh my goodness, stop. Why won't it stop writing? I don't know what's going on here. It just wants to keep going and keep writing. Okay, let me see if I can pause the video and come back. All right, now managed to wrangle it and get it under control. So here's what I wanted you to see is that if you do the change of base here, remember that we do have some domain restrictions with our logarithms, right? And so notice if I try to do log of -3, there's no real answer, right? So just remember that the logarithm, right, we have to take the log of a positive number, all right? So we can never take the log of a negative number. So just wanted you to be aware that that does happen sometimes. You can get a no solution as well. All right, my friends, that wraps up, all right, our lesson on solving exponential equations. All right, so give the homework a try. All right, let us know if you have any questions. We look forward to chatting with you, and we'll see you again for that final lesson in this unit. Take care. See you later.